We hope you never want to miss an episode of Big Picture Science, and here's another way to ensure that you don't. Be among the first to listen to Big Picture Science on the new podcast service from Pandora Music. BiPi was selected to be part of the launch of the Podcast Genome Project, and you can sign up for beta access today. You'll find a link on our website at bigpicturescience.org. And just a reminder, you can also subscribe to BiPi on iTunes, Google Play, Stitcher, Spotify, and iHeartRadio, among many other podcast services.
When I was a kid and very suggestible, I saw this film produced by George Powell, which was called When Worlds Collide. Well, some astronomers find a star that's going to collide with the Earth. Well, this was the first time that I'd ever been exposed to the idea that something from the skies could come down and hit us and cause havoc and destruction. Later in life, I realized that the real threat wasn't from stars that were going to collide with us, but rocks, asteroids. So asteroids have sort of a bad rep, but they really shouldn't, because most asteroids are not going to hit us. They're little things, and yet they're scientifically very interesting. I'm Seth Shostak.
I'm Molly Bentley. Welcome to Big Picture Science, produced at the SETI Institute, where researchers investigate the nature and origin of life. In this episode, why asteroids are both our past and our future. We no longer have the historic incentives to go into space, in particular, competition for geopolitical dominance by planting a flag on another cosmic body. But space entrepreneurs say they have another carrot to motivate us to leave terra firma, the trillion-dollar asteroid mining business. Not only will it get us into space, but it will help keep us there. Meanwhile, for deep history buffs, an upcoming flyby of the Kuiper Belt asteroid is likely to give us new clues to the early days of the solar system. And one particularly odd-shaped interstellar object has ignited our imagination in other ways. We'll consider the argument that Oumuamua is actually alien hardware. Get ready for Space Rocks.
There are generally 3 reasons to go into space, maybe 4, but the first is geopolitical. The Soviet satellite Sputnik streaked overhead in 1957. It was a rude wake-up call to every rocket engineer in the country. And within a few years, President Kennedy inserted putting a man on the moon high into our national to-do list. It was about exploration, yes, which is the second reason to go into space, but of greater import, it beat a rival superpower to the punch.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
But we no longer have that national rivalry to motivate launching ourselves skyward. We'll hear a modern case for going into space later. But first, a look from whence we came and where NASA took us, from a man with the peerless knowledge of the history of the space race.
I'm Roger Launius. I am an aerospace historian. For many years, I was a curator and then associate director at the National Air and Space Museum at the Smithsonian. Before that, I spent 12 years as the NASA chief historian.
Roger, it's been said that when future generations, say a millennium hence, think back on the 20th century, it won't be the political developments they remember, not even the 2 world wars. It will be the fact that we sent men to the moon. Is that true, or is it just hyperbole?
Well, it's certainly true at some level. There'll probably be a couple of things that'll be remembered, say, 500 years in the future. One of them will be the moon landings, the first time humans set foot off of this planet and went to another body in the solar system. That's clearly significant. I would suggest another one that we'll remember that has nothing to do with space exploration, but is symbolic of the space race in the Cold War, is the atomic bomb and the possibility of destroying ourselves with nuclear weapons, which sparked the space race.
The atomic bomb fleet rendezvous for A-Day. The decks of the 73 test ships anchored in Bikini Lagoon are scenes of feverish activity as scientists plot experimental programs designed to furnish data on radioactive rays, flash burns, and blast effects of the mighty atom bomb. Even with these goggles, they saw a stab of light as brilliant as lightning, while those without goggles turned their backs and shielded their eyes with their arms.
Well, you have to elaborate on that. I mean, how did the mushroom clouds put men on the moon?
Well, one of the things that was happening is we were in a death struggle with the Soviet Union. There's no question about that. And for those of us of my age and those that are older, we can recall this was serious business, and we have nothing like this today. So that rivalry and that intense competition between these two competing and economic systems that are political and all kinds of other ways really gave us this competitive activity that was played out in a lot of settings, but one of them was the race to the moon.
Buzz, this is Houston, F2, 1/160th second for shadow photography on the sequence camera.
Okay.
It was clearly a truly remarkable engineering achievement, going to the moon with people aboard, and it was done in a stunningly short amount of time. Was there some secret sauce for the American effort? I mean, why did we get there first? The Soviets, after all, had some pretty good rockets.
The Soviets had an early lead in space. There's no question about that. They were successful in putting up satellites before the Americans could. They were able to launch Yuri Gagarin into space before the Americans could do the same with our astronauts. So they used an early set of capabilities that they had built. And interestingly enough, they had built a big rocket to do these things because everybody's trying to build ballistic missiles. The Americans and the Russians are both engaged in that. The Americans had technologies that allowed them to miniaturize what they were doing with the electronics and with the warheads as well. So they didn't need as big a rockets, so they were smaller. The Russians did not have that same technology, so they built the biggest booster they could. It was a good booster, and it was successful in launching all of these things. But that early lead got wiped out quickly when the Americans sort of began to really race them, and the technological base was very strong, and we were able ultimately to win.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
When the Americans successfully set foot on the lunar surface, the Russians didn't necessarily recognize that they were fully beaten at that point, but they realized they did not have the same capabilities, and they were willing to accept the fact that the U.S. had won.
And that leads me to ask you, is the public still enthralled by going into space, or do we only go there when there's geopolitical pressure?
Well, you know, we're only willing to expend large amounts of money when we view something as a threat. That seems to be the case all the time, regardless of the subject. And that's certainly the case in the context of the Cold War space race. We're willing to spend some money on this to the tune of roughly $20 billion a year today in terms of space exploration. And that's not chicken feed, but it's not the kind of dollars that would be necessary to undertake these other kind of very aggressive programs. Politicians and the general public is happy to let NASA bump along at sort of that 0.5% of the federal budget, which is kind of what it's been for about 30 to 40 years now.
All right, so what you're saying is that there's interest in space, but not any more interest than there was before we went into space.
One of the things that captured my generation growing up in the 60s was this thing that was new and different.
NASA officials have high hopes for the flight of Collins and Young. If the mission achieves the link-up between the Gemini craft and the Agena rocket, it will be considered a success.
And for those that are my age, they may be interested in this, but it's not new and different. And therefore, it's not exciting in quite the same way. And we're, as a society, we're all about the thrill, whatever the thrill is, and it changes pretty regularly. Although, whenever there is an event that is significant, people do pause and they pay attention and they're excited by it. So a great example is the Curiosity landing that just took place a few years ago, in which you've got people who've come out in the middle of the night to Times Square to witness the landing, which of course they couldn't actually see, but they saw the feed from NASA, who are chanting, "Science, science, science." I mean, that's sort of thrilling in its own way. So I think that excitement is out there. It doesn't pop its head up too much except when there's major events.
What do you say to people when they ask you about the relative merits of sending, or should I say, instead of asking, maybe they just expound on their personal opinions regarding the relative merits of sending humans into space versus sending robots? I mean, obviously the robots are cheaper and they don't insist on a round-trip ticket.
Yeah, that's one of the great things about the robots is they're on suicide missions. And we don't really care. I mean, we want them to survive as long as possible, obviously. But we don't have to bring them home. And the first task of any spacecraft that has a human aboard is not to do anything other than bring them back alive. So it is a cost-effective way to do a lot of exploration activity. And I think many people understand that. And there's still a special place in most people's hearts for astronauts. But it's not that they're the end-all and the be-all of this space exploration activity.
So do you think we're going to have space colonies in this century? You know, settlements on the moon or Mars? I mean, I've seen them in the movies plenty often.
So how long do you plan to stay on Mars?
2 weeks.
Have you brought any fruits or vegetables onto the planet?
2 weeks.
Excuse me?
Yeah, it's a trope in the movies that everyone loves, and myself included. It's something that I would look forward to. It's something that's not very likely. And let me explain why. You know, we can put boots on the ground on the moon and Mars. We can probably do it in some of the moons beyond. And that's great. But, you know, Apollo was essentially a camping trip. They went for a few days and they did some things and then they came back. And going to the next step, which would be some sort of maybe research station, I think we can also do. The reality is that'd probably look a lot like Antarctica, where you cycle people in and out on a regular basis, and they're there to do some specific sets of tasks, scientific pursuits, whatever it happens to be, and then they come home replaced by some other people. But once you move from that to the idea of a colony, then you're opening up a whole series of questions that very few people have actually thought very much about. When you send families to live and have children and who would grow up and live there and die there, that's a whole different ballgame. And the one thing about life on this planet is that we are all engineered, very well engineered and evolved to survive at 1G. So what happens to the human body in a 1/6 gravity on the moon or a 1/3 gravity on Mars, absent any of the other issues? A body that is procreated in that environment and is gestated in that environment and is born in that environment, how are they different? And what does that really mean for us as we think about the long-term future of humans in space? Does that mean they're Homo sapiens any longer? I mean, maybe it's another species that's related to us. Those are issues that very few people talk about and nobody at NASA wants to talk about.
Roger Launius, thanks so very much for speaking with us.
My pleasure. Thank you.
Roger Launius is an aerospace historian and former associate director of the National Air and Space Museum at the Smithsonian, as well as a former NASA chief historian. Well, it sounds like what he's saying is that the usual incentive to go into space, or at least the historical one, the one that got us there in the first place, isn't there anymore. Political rivalry.
That's right. And the race to the moon was, after all, a race, and the U.S. won the race. Now, immediately afterward, there was a plan to send humans to Mars that seemed to be the logical next thing, a follow-up mission. But it turned out that once the geopolitical stimulus was gone, people had other uses for the money that would have been spent sending people to Mars. Of course, the geopolitical incentive might come back if other countries were to, for example, establish a colony on the moon or take their own astronauts to Mars. But at the moment, there's definitely not quite so much eagerness to hurl Homo sapiens into space just to prove that our country is better than someone else's country.
Well, that leaves us with 2 or 3 incentives for going into space: exploration and science, sometimes they're put together, and economics. We'll take a look at the last one first because the others may follow from it, according to this man who says there's a profit to be made in space.
So if we're going to stay in space and thrive there, then we need to live off the land, as it were. And for that, we will need resources such as water, which is abundant in certain types of asteroids.
Next, the argument for both stimulating and sustaining humanity's spacefaring future by mining asteroids. Then, later in the show, is one weirdly shaped solar system intruder actually a bit of alien engineering?
It's Space Rocks on Big Picture Science.
You know, unless you're a broker, your confidence level when buying and selling stocks, ETFs, options, and cryptos is probably lower than a platypus's belly. But there's a game changer out there, Robinhood, an investing app that anyone can use and that lets you invest like the big boys without intimidation and without a commission fee. With its simple and intuitive interface, Robinhood lets you build your wealth with a handful of taps on your smartphone. Oh, and did I mention that there are no commissions? Compare that to other brokerages who charge up to $10 for every trade. So keep all your profits and avoid the bewildering complexity of the big brokerages. Robinhood is simply a better way to get into the market and start growing your nest egg. And now Robinhood is giving Sci listeners a free stock like Apple, Ford, or Sprint to help build their portfolio. Sign up at bigpicture.robinhood.com. That's bigpicture.robinhood.com. We've been talking in this episode of Big Picture Science about the loss of a major historical incentive, geopolitical rivalry, that once motivated humans to go into space. Now, by way of introducing a new and potentially very important player in the game of human spaceflight, we first recall that the only image that many people have of this particular player is as a trope of science fiction.
What is this thing?
It's enormous.
It's an asteroid, sir. It's the size of Texas, Mr. President.
What kind of damage?
Total, sir.
My God.
A killer rock hurtles toward Earth and only Bruce Willis can save us. Well, with or without Mr. Willis, destruction is what many people imagine when they think of asteroids. And while the movie Armageddon was fiction, the idea that one day Earth will be the bullseye for a space rock is solidly rooted in fact. It's already happened, of course. Impact is the main suspect in the extinction of the dinosaurs, as well as most of their fellow fauna, 66 million years ago.
But NASA is diligently cataloging all the potential dangerous asteroids in our neighborhood, allowing us to relax, at least for a little while, and contemplate the ways that small orbiting bodies can be beneficial.
These space rocks may provide an incentive not only to get humans hurtling into space again, but to help us stay there. We heard that building a space colony is, well, not a piece of cake, but if you're going to do it, you're going to need what this man says he can provide, according to this man.
J.L. Galache is an asteroid astronomer turned entrepreneur, although he says he's not so much an entrepreneur as an astropreneur.
Dr. Galache is co-founder and CTO of Aten Engineering. That's a firm that provides technical solutions for the discovery of near-Earth asteroids and eventually for their exploitation for resources.
His goal is to capitalize on these space rocks to pave the way for the human re-entry into space. In other words, if contemporary reasons to go are exploration, science, and economics, that last one may help us with the first two.
JL, you're interested in commercializing asteroids. Nobody's ever done that. What's there to be gained monetarily from looking at asteroids or doing something with them?
Well, the standard answer is trillions of dollars. And we like to say that the first trillionaire will be made in space. My motivation for this is that I want to see humans expand into space.
So what do the asteroids bring to the table, as it were, for this? I mean, people talk about having colonies on the moon or on Mars, whatever. People occasionally have even talked about having colonies on the asteroids, but you're not offering the asteroids as real estate. You're offering them as goods, as it were.
Yeah, they are a means to an end. If you think about any of the great migrations that have happened throughout human history, they've only been possible because humans have learned to live off the land. We didn't set off and cross the plains or the mountains with everything that we needed on our backs, but we would find food, water, shelter along the way. And that's how we were able to expand humanity all across the globe. So if we're going to space and we're going to stay in space and thrive there, then we need to live off the land, as it were. And for that, we will need resources such as water, for example, which is abundant in certain types of asteroids.
Is it naive of me to assume that whatever resources that you need, including water, by the way, for a colony on Mars are part of Mars? I mean, why don't you just dig up Mars? Why involve the asteroids?
So if you're going to Mars, you probably want to be using the water that's in Mars. And that's great because we believe that there is water in the subsurface of Mars, so you can just dig it. But if you're going into free space, so if you're thinking about space hotels or space settlements that are floating, then you need to have water from somewhere. Water is going to be the oil of space because it's very useful. Humans need it to survive. You need to drink it. You can also break it up into hydrogen and oxygen. The oxygen can be used for breathing, which humans need. It's very good for us. And you can create rocket fuel out of the hydrogen and oxygen as well.
But wait a minute. You know, you're talking about the asteroids because certain kinds of asteroids have water. But the Earth has plenty of water. Why don't we just lift the water up into space with a rocket and take it wherever we need it?
So how much money have you got?
Is that related to this interview?
It will be if you wanted to take your own water into space. Right now, to take a liter of water, you can pay $10,000, for example, to lift the liter of water to the International Space Station, right? So imagine that you're able to mine water from asteroids and deliver it to the ISS for way less than $10,000. There you've got a business model.
Okay, I'm listening to you tout the advantages of mining asteroids. Maybe you can give me a little bit of insight as to how you do that. Do you go out with a big net and grab an asteroid and somehow take it out of whatever orbit it's in and bring it nearby and, mine it with astronauts that go up into nearby space? Or do you mine it in situ? Do you have robots doing the mining? How does this work?
So maybe that's the tricky part. There is a lot of technology that's already been developed, right? And there are different people with different ideas. So I'll give you a couple of possibilities. One of the asteroid mining companies is called TransAstra, and they're in Los Angeles. And they've developed what they call optical mining. So their plan is to put small asteroids, like 8 to 10 meters, into a big bag. And at one end, there is a solar collector, so kind of like a parabolic mirror, that collects sunlight and concentrates it into an opening in the bag that hits the asteroid. And then you get what's called spallation. So you basically sort of boil off a very thin layer of the asteroid. And if it's the right type of asteroid, one that contains water, then this water will evaporate and it will collect in a container that's attached to the bag. Now, that only works for smaller asteroids. So if you're going for bigger asteroids, then you have to use some sort of machinery. And you want to make this affordable. You need to turn a profit. So you're not going to use astronauts. So all this is going to have to be automated with robots. And you'll have AI systems. And there'll be different types of robots that perform different types of tasks. Some will probably be crushing the rocks to make them into a finer powder. Others will take this fine powder and there'll be some heating involved, maybe chemical processes to extract whatever materials you want to extract. And this means that you are mining in situ.
Now, I've heard it said that asteroids contain a lot of precious metals, things like platinum and so forth, that are, in short supply around here. We need them for various industrial purposes, let alone jewelry. And we could find these in the asteroids in such abundance that it's worth the shipping cost to bring it back to Earth. Is that true?
How can I say no without sounding like a joy killer?
Oh, you could say yes.
I could say yes. It's become a trope, I think, to talk about the $5 trillion metallic asteroid that has so much platinum that it's going to crash the markets here on Earth. And as an asteroid prospecting company, part of the research we're doing is finding out what materials you can find in various types of asteroids and in what quantities. And what I'm finding in my literature research is that there isn't that much platinum in asteroids. We're talking about, in the best case scenario, concentrations of like maybe 1 part per million, 2 parts per million. And 1 part per million means that you need to mine through 1 metric ton, to get 1 gram of that material.
All right, I'm not buying stock in your company until you tell me what other things the asteroids have to offer, besides the water, of course, that are worth my investment.
That is not platinum. Well, let me say not gold, because I've also heard an asteroid made of gold. That's not going to happen. That there is gold, but again, it's pretty much like platinum. Rare earth elements is something that's mentioned a lot. Again, there's not that many of them, because what happens on Earth with mines is that there has been, through some geological process, materials have concentrated in a specific area, and a mine has been set up there, right? What happens in asteroids is that you have all these materials mixed up. It's like a cake. You put raisins, M&Ms if you like it, anything else you want to put, sesame seeds, right? And you mix it all up. So if you cut the cake, you'll see that there are sesame seeds, raisins, and everything else is everywhere throughout the cake. So that's what asteroids are like. There's no concentration. So it's not like a traditional Earth mine. So in order to mine anything, you have to go through a lot of material. And I believe that eventually we will mine for these elements, but they will be a byproduct of having mined something else in the asteroid first. So what else can we find apart from water? Iron. Most asteroids are at least 30% iron by weight. So that can be very useful in space. Nickel is also quite available, and silicon. Now, silicon, you know what you can do with silicon?
Well, you can make some electronics with it, perhaps.
Exactly. You can make electronics. You can make solar panels. So imagine if you can get some iron, some nickel, some magnesium, some silicon, and you start building stuff in space. And you can build solar arrays. They can build them as big as you want. You could have a 1 kilometer square solar array if you wanted.
Well, finally then, JL. When's this going to happen? When are we going to see the first, actual mining being done in space?
Isn't that the question that everyone's asking?
I don't know.
It is. So I think that we could begin mining in as little as 5 to 7 years. And then you could see actual industrial level mining in 10 to 15 years.
JL Galache, thanks so very much for talking with me.
Well, thank you very much.
J.L. Galache is an asteroid astronomer and co-founder and CTO of Aten Engineering. All right, well, asteroids may be physically small, but they're conceptually quite significant.
Yeah, well, I really like the way he talked about how water was the oil of space. In other words, emphasizing how important it is. The problem with water is it's heavy. So if you're in orbit somewhere on some space station of some description, you can't just bring the water by rocket up from the Earth. I mean, it costs too much money. He says it's a heck of a lot cheaper to mine an asteroid. 1/5 of an asteroid is water, he says. So you get the water out, and then you just bring it in space to where you need it. That would be a lot cheaper.
Of course, the comparison of water to being like oil, well, here on Earth, the thirst for oil has caused political and socioeconomic problems and great rivalries. Wouldn't we expect the same in space?
Well, there might be battles over water. I mean, if that's what you're trying to say, that's conceivable, I suppose. I tell you, something else that he said that really surprised me, because when I think of the resources in an asteroid, I'm thinking of those precious metals, the platinum, the rare earths, the gold. And he points out that his research suggests only 1 part in a million of an asteroid is actually platinum or gold. So that didn't sound so enticing.
Right, but there's iron, there's silicon. There's silicon. You could make computer chips in space.
Well, that's right. You could have your cell phones made in space. Dr. Galache points out that the asteroids are a great resource for the things you need for a, highfalutin lifestyle. He didn't mention the idea of Freeman Dyson, the British physicist, that our progeny may actually live on asteroids. And you may wonder, what's he talking about there? But you see, the problem with the Earth is there's a lot of stuff in the Earth, but the Earth is round. And so you don't get much acreage for all that stuff. Whereas if you were to cut up the Earth and roll up the halves, you get a lot more acreage. Well, you can just consider the asteroids. They have 10,000 times more acres than the Earth does.
Physicist Freeman Dyson's idea is that at some point, humanity will move off Earth and onto asteroids?
I don't know that he's suggesting that we abandon the Earth, but if you want to grow the population to 50 billion or 100 billion, where are you going to put them? You can say put them on Mars, but that only doubles the amount of space you've got. If you go to the asteroids, you have this enormous possible increase.
How far away are the asteroids? You mean in the asteroid belt?
Yeah. The asteroids in the asteroid belt. I mean, maybe you'd want to move them. Now, one problem with the asteroid belt is it's pretty far out. It's farther than Mars, so you get, maybe only half the sunlight that you get around here.
And what would it be like to live on an asteroid?
Well, I don't know yet. I think you'd probably be living underground. There's no air, and there's no liquid water on the surface, so no surfing or stuff like that. You'd probably live, I don't know. I mean, you're just going to have to ask the architects of your next planned unit development on an asteroid.
But then what if you're living on an asteroid and it gets ejected out of the asteroid belt?
Well, that doesn't happen very often. It really doesn't. I mean, I don't think that happens.
Which part? Living on the asteroid or it getting ejected out of the asteroid belt?
Both parts. Nobody's living on an asteroid right now that we know about. Okay. But getting ejected, in the movies, the asteroids always look very close together. They're an impenetrable barrier of all these rocks floating around. And then they would indeed occasionally kick one another around. But in fact, they're usually millions of miles apart.
Well, from how asteroids might guide us into the future to what they may say about our past. An exciting new flyby by the New Horizons spacecraft may reveal the secrets of the early solar system.
It's a first close-up look at the oldest and coldest object we have ever seen. There's been a lot of planetary exploration over the years, including a lot of asteroids and comets, but Ultima Thule is a different category of object. It is a remnant, a witness to the formation of the solar system itself.
That's coming up, along with a discussion with the top astronomer who thinks that one oddly shaped object may not be an asteroid, but a piece of alien hardware.
It's Space Rocks on Big Picture Science. We've been talking in this episode of Big Picture Science about the solar system's rock stars. Asteroids may be small, but as we're hearing, they're hardly insignificant. We heard how they might be mined for water, iron, and silicon, which would be useful raw materials to build human outposts in space, but their chemical composition also motivates astronomers to study these objects up close.
In the last half-century, as we've learned more about how the planets and moons were formed, we've come to realize that the small bodies of the solar system were maybe the best sources of information about how that happened.
Unlike planets, asteroids haven't been distorted in the 4 billion years since the solar system was born by weather or plate tectonics or the slow erosion by atomic particles and radiation in space. Asteroids are like dinosaur bones, important clues to what existed in the past.
Remember the New Horizons spacecraft flyby of Pluto in 2015? Well, the spacecraft didn't rest after scrutinizing Pluto. It's been traveling ever since, and it is now deep into the dark wastes of the outer solar system, the Kuiper belt, and it's about to make a second historic visit as it nears an ancient Kuiper belt object named Ultima Thule. Thule is a frozen remnant left over from the birth of the solar system.
Planetary scientist and a senior research scientist at the SETI Institute, as well as a member of the New Horizons team, Mark Showalter, tells us what to expect from this second encounter.
So we're about to encounter an object that has the nickname Ultima Thule. It is a Kuiper belt object. It is about 1 billion miles beyond Pluto, so way out in the far distant reaches of our solar system. The Kuiper belt is a collection of about maybe a few tens of thousands or perhaps even 100,000 objects that are kind of left behind in deep freeze from the early days in the origin of the solar system. And we will get our first close-up look at one of these bodies in a few months.
Are they asteroids?
They are not asteroids. They are similar to asteroids in size, but they are much further from the sun. Most of the asteroids are between Mars and Jupiter. And so objects out beyond Neptune tend to be called Kuiper belt objects.
What's the difference between the Kuiper belt and the asteroid belt?
Mainly its distance in terms of just how we categorize objects. The objects in the Kuiper belt have been there mostly in isolation in deep freeze since early in the days of the formation of the solar system. The asteroid belt is a little bit different in that it is closer to the sun and therefore warmer, and therefore there's been a lot more surface evolution. So we're getting a look at a very, very pristine object, which is not quite the same as what you would see if you got a close-up look at an asteroid, as we have on a number of occasions now.
Well, let's say more about why this visit to Ultima Thule is historic.
It's a first close-up look at the oldest and coldest object we have ever seen. There's been a lot of planetary exploration over the years, including a lot of asteroids and comets, but Ultima Thule is a different category of object. It is a remnant, a witness to the formation of the solar system itself.
So even older and colder than Pluto.
Absolutely so. Pluto has actually evolved quite a lot because Pluto has an internal heat source, which is why there are glaciers and an atmosphere. I mean, Pluto is an extraordinary world. Just everyone still on the team is marveling over the data from the Pluto flyby. But this is basically what you would get from a piece of Pluto that is so small that it basically never evolved, and it is still exactly the way it was 4 billion years ago.
So what might we learn from Ultima Thule because of that? It's kind of suspended animation, if you will, in composition. What could it tell us about the early solar system?
Well, we'll certainly get some information about composition. What were the materials around then that aren't around quite so much now? Now, probably that's sort of the common makeup of the solar system is things like methane, nitrogen, ammonia. These are the very basic, water ice, of course. These are the very basic things that make up the solar system today, and we suspect to see a lot of that. But we don't know what the mixture is. We don't know what other things might be there. So we'll get some very interesting composition information. We could see some, what we see is a spectrum. The way the sunlight is reflected off this object tells us a little bit about the composition. And if there are sort of exotic chemical compositions that don't really exist so much in the solar system today, but were around earlier, we would see that as maybe some mysterious molecular lines that we would have to speculate what they are.
Now, how close will New Horizons get to Ultima Thule?
Well, that is a decision that is yet to be made.
Still needs to be made. You guys at NASA, and you guys plan these things months and months, years in advance, don't you?
And we do, and we also plan contingencies like all good Boy Scouts or Girl Scouts. The idea is, because we are flying into the unknown, we don't know what is a safe flyby distance. So we have made two choices. And those choices are to fly by a distance of 3,500 kilometers, which is about 2,500 miles, or 10,000 kilometers, which is about 6,000 miles. We believe that the outer of those two distances is almost certain to be safe. But you never know because many objects in the Kuiper belt have satellites. Some have rings, or at least one has rings that we know of. So I am actually leading what's called the hazard team. Now that sounds a little funny. You think of a hazard team as looking for toxic waste or something like that. But we're actually effectively riding on the crow's nest of New Horizons. And we are going to be looking at images day by day, very, very long exposures, looking for anything that might be nearby to Ultima Thule and might potentially be dangerous to us. And if we see anything, such as a dust cloud or a coma or a couple of satellites that might suggest that there is a danger to flying the closer of alternatives, the 3,500 kilometer option, then we will divert to the 10,000 kilometer safer distance. Hopefully we won't see anything dangerous. We'll have exactly the flyby we want. But definitely looking for hazards is a big part of this effort.
Now, it is a flyby. It's not a landing. And so what information will you collect from Ultima Thule?
Primarily, we're looking at images that will be either black and white photos taken with our high-resolution camera. We also have a color camera that has slightly lower resolution, but we will be getting color, and that's also part of how we'll be getting the composition information. But we're flying by very quickly. It's a 14 kilometer per second path. That's 9 miles per second. And our object is about 18 miles across, so that's a 2-second flyby if you think about it. But in fact, we're really doing imaging. We're doing imaging now, but we will continue to do imaging for the whole period before, during, and after the flyby, giving us lots and lots of images, which we will then have to wait for them to be shipped down to Earth, because during that 24-hour period or so around the flyby, it's going to be doing science and nothing but science, and we just have to hope we got all those instructions right, and it'll do the right thing, and then we'll find out after the fact that we got the good data.
Patience is part of rocket science.
Patience is definitely part of rocket science.
Well, finally, Mark, after the encounter with Ultima Thule, New Horizons keeps on going, which must be melancholy for you, must be bittersweet. It's been a very successful mission, but at some point we need to say goodbye to New Horizons. What is the fate of the spacecraft? Will we hear from it again?
Absolutely. We are still doing observations of other Kuiper Belt objects. These are distant observations. We will not have another flyby because by the time we get to Ultima Thule, we've actually crossed most of the Kuiper Belt already. So this is our last big hurrah, but there will be good science coming out of New Horizons for a very long time because we're still looking at many other objects. But I think the exciting part, the biggest exciting part, will be ending in January. I would just also add that, as far as I'm concerned, although it's bittersweet, seeing our spacecraft fly off into the galaxy as a little piece of humanity that explores the galaxy forever, I love that idea. I was also on the Cassini mission, and watching our beloved Cassini spacecraft go burn up in the atmosphere of Saturn was a much more traumatic experience for me. I love the idea of New Horizons flying off forever.
Well, Mark Showalter, it's great to see you again. Thank you so much for joining us.
Always a pleasure, Molly.
Mark Showalter is a senior research scientist at the SETI Institute and a member of the New Horizons team. Well, a space rock like Thule may tell us something about how Earth was born, and as we were putting this show together, another space rock made the news. A quick note about that. Scientists in Denmark have announced the discovery of an asteroid crater under the ice cap in Greenland that may reveal more recent history. The crater is, rather coincidentally, less than 200 miles north of Thule Air Base. It was created when an asteroid slammed into Earth during the last ice age, and if we can get to it, well, it is beneath a half-mile of ice, it may provide information about the conditions on Earth tens of thousands of years ago. So once again, asteroids may help us to understand history.
We have one last asteroid story, and this one really is out there. In 2017, a telescope in Hawaii discovered an object moving through our planetary system. Oumuamua, as it was named, was thought to be an asteroid or maybe a comet. This is the first time we had seen an object that originated outside our solar system.
Its origin and its unusual cigar shape led some people to hypothesize that the object was an interstellar spacecraft, akin to the one depicted in Arthur C. Clarke's story, Rendezvous with Rama. But there was really no evidence for that, and most astronomers have reverted to the original idea of it being a rock from space.
But not all astronomers. In a recent paper, scientists at Harvard University claim that Oumuamua could be a piece of alien hardware. Now, this is a radical suggestion, but lead author Avi Loeb, chair of Harvard's astronomy department, says it's worth considering. He suggests the space rock could be a piece of alien space junk, specifically a solar sail propelled through space by starlight.
Yes, so Oumuamua is the very first interstellar object to have been discovered close to the Earth. And in that sense, it's quite surprising because about a decade ago, we forecasted how many rocks should we see from outer space in the vicinity of the Earth. And we predicted that existing surveys would not find any because the abundance is not large enough for them to come close enough to Earth for them to be detectable.
All right, so if I understand the motivation, to begin with, it comes into our solar system. That sounds a little improbable. It's like throwing a dart up into the air in New Jersey and hitting a nickel in Manhattan. Not very likely, unless it was maybe deliberately sent here. Is that part of the problem?
Yeah, but this object by itself is quite weird in the sense that it's very cold. It didn't absorb as much sunlight as, for example, rocks absorb. Spitzer Space Telescope looked at it and didn't see any heat coming off it. And from that, we can infer also that there are no gases around it. But most intriguingly, its trajectory deviates from an orbit that is shaped purely by the gravitational force of the sun. And one way to get that is if you have a cometary activity, if there is some outgassing that push the object in the opposite direction through the rocket effect. But we don't see any cometary tail. So that's very puzzling.
Well, let's consider the possibility that you put forward in your paper there that it's someone else's hardware, either deliberately sent here or just wandering in, maybe a solar sail. Tell us what a solar sail is and how does it push a space probe around? I mean, there's no wind in space.
So the only additional force other than outgassing that I could think of is the force exerted by the radiation from the sun on the object. And in order for that to be effective, the object needs to be very thin. So we calculated the needed thickness of the object. It needs to be less than 1 millimeter thick. And its size, however, needs to be about 20 meters. And so that sounds like a sail. A sail on a sailboat is being pushed by the wind, by air bouncing off it. The same phenomenon occurs when light bounces off a surface. It exerts some force on it. And so that's called a light sail. And we are currently developing this technology for space exploration. It was demonstrated by a Japanese satellite called the Icaros. And currently we're contemplating a project called Starshot to send a probe to the nearest star using this light sail technology.
Now, you've gotten quite a bit of pushback, I think, from other people in the science community who say that, well, look, to argue that it comes in a way that mimics what you would expect for a rock from space, you're interpreting that as being the result of very clever engineering. But on the other hand, there's also the obvious explanation that it really is just a rock from space. What do you say to that?
Well, it doesn't look like any of the asteroids or comets that we have seen in the solar system. For one thing, the light curve, the reflected sunlight, as it rotates around, changes by a factor of 10. And so that implies that it has a very extreme shape, that it is at least 5 to 10 times longer than it is wide. And moreover, it doesn't show any cometary tail, any gases, carbon-based gases around it. And so it doesn't look like a comet either. So what's the chance that the very first visitor from outer space would not be anything like the asteroids or comets that we have seen in our solar system? And I don't believe that this object can be an outlier. The situation is similar to going to the beach and looking at the seashells that were swept ashore. But every now and then you get a plastic bottle that implies an artificial origin. And so I think we should examine every interstellar visitor and see where it may have originated from. Unfortunately, this object came by surprise. So it's sort of too late now to chase it down with chemical rockets. And what we need to do is wait for the next visitor.
Avi Loeb, thanks so very much for speaking with us.
My pleasure.
Avi Loeb is an astronomer at the Harvard-Smithsonian Center for Astrophysics and the chair of the Department of Astronomy at Harvard University. Well, Seth, if I could take a stab at summarizing why he thinks that this object is not a comet or an asteroid, okay?
Okay.
Well, it's unexpected to have a foreign object in our solar system. It has a funny trajectory, which would be understandable if it were a comet, but it doesn't behave like a comet in other ways. Well, first of all, how it looks. It has a strange cigar shape. It's longer than it is wide, and it doesn't have the outgassing or the tail of a comet. Do I have that right?
That's right. You could understand the motion of this object if it were a comet, but it doesn't seem to be a comet, and that's what prompted the paper.
Do we know for certain it's not an asteroid or a comet?
We don't know for certain, because the observations are still limited.
So is it reasonable then to conclude that it's an alien ship or even part of an alien ship?
Well, I mean, the only natural explanations that came to the fore, if you will, are asteroids or comets. And if it isn't either of those, then what's the next thing you think of? it's always tempting to explain something that seems a little puzzling at first as being due to aliens. That's maybe too easy to do, and that's why a lot of people are a little bit skeptical here. I think that the astronomical community is thinking that extraordinary claims require extraordinary evidence, and the evidence that it's artificial is not yet so compelling. And unfortunately, it will probably never be, one way or the other, compelling, simply because the object is essentially unobservable now.
So we may never know.
We may never know about this, but if we find a second object in 2 years or 3 years or 5 years, and it also has a cigar shape, right, and it also has these other characteristics that Loeb has talked about, then he would say, build a super-duper rocket that can catch up with one of these guys and take a look at them up close.
Well, so the big picture here in the show is that asteroids capture our imagination in many ways. And as we said, even though they're small, they're not insignificant.
Yep, time capsules they are. And, 200 years ago when they began to discover these asteroids, the ones in the asteroid belt anyhow, they were little dots in the telescope. They didn't know what they were, and they were fun to look for. The Europeans organized a whole project to look for them, but nobody would have been able to predict that these things would in the future be so scientifically interesting.
Thanks to the team of rock stars that helped produce this show, senior producer Gary Niederhoff, assistant producer Sarah Derwin, and operations manager Barbara Vance.
Thanks also to financial support from Rena Shulsky-David and Sammy David, and to the William K. Bowes Jr. Foundation. Big Picture Science is produced at the SETI Institute, a nonprofit scientific and education organization whose scientists study the origin and nature of life, including the behavior of rings around planets. And a big thanks also to our listeners.
Your ears have been attuned to an episode of Big Picture Science called Space Rocks. If you'd like to hear more Big Picture Science, well, you'll find past episodes in our archive at bigpicturescience.org.
Oh, and if you never want to miss an episode, subscribe to BiPi-Sci on iTunes, Google Play, Stitcher, Spotify, iHeartRadio, or Pandora.